All right, so we've talked about how in some cases we need to do a use substitution, and then in other cases we can just go ahead and do the problem. Another thing we might want to do is just look at our green sheet. So if you have your green sheet, you might want to get that out as well. All right, so on this first problem that we have here, we have to decide, is this just a basic integration formula? Well, no, it's not. We can see that by looking at it. It's not a basic problem at all. Next thing we do is we try a use substitution. On this one, though, a use substitution is not going to be effective. The use substitutions only work on this kind, when that power in the denominator is greater than the power in the numerator. Because here, if I do a use substitution, that derivative was 3x squared plus 1 dx. And that was equal to the rest of the problem. So then I was just left with the integral of, that all was du, 1 over u. And we know that integral of 1 over u from up here is just natural log. So this one was just natural log of our u plus c. But that's not the case over here. Okay? I can't let u equal the denominator. So this was the situation where we had to do the division. Sometimes the integrand must be changed with long division, and that's what we're going to have to do here. Or we can do synthetic. All right? Which do you guys prefer, long division or synthetic? Synthetic, okay. So we'll let whatever would make this equal 0. That would be a 2. And so I use my coefficients, 3, 8, negative 4. So I bring this down. That's 3. 2 times 3 is 6. We add. 2 times 14 is 28. We add. This is always going to be our remainder. So another way to write all of this would be the integral of 3x plus 14 plus 24 over what we were dividing by. If I were to go through this and get a common denominator, combine it all, it would go back to that again. That's not what we're doing. We wanted to break it down into individual terms. So now the integral of 3x, we have to add 1 and divide. The integral of 14 is 14x. This integral, I have to do a u substitution. U is x minus 2. Du then is dx. So right here, that's du. So I still have this really, plus the integral of 24 over u du. Well, the integral of 1 over u is going to just be natural log. So we're going to have 3x squared over 2 plus 14x plus, this will be 24 natural log of u, but u was x minus 2. So that's going to be our final answer. Number 2, the integral of tangent of 4x. Well, we don't know an integral of tangent, but we can look at our green sheet. The integral of tangent is right here, number 15. But notice that it says that our angle has to just be a u. So I have to do a u substitution here. I'm going to have to say u equals 4x. So du then is 40x. Well, all we wanted was a dx, so I'm going to have to multiply by 1/4. So now we have 1/4 the integral of tangent u du. Looking back at that, the integral of tangent u is negative natural log of cosine u. So it's negative 1/4 natural log of the absolute value of cosine u plus c. Just applying that formula. We know that coefficients just get brought down. All right, for number 3, you think about, the first thing that comes to mind on this is a u substitution with u equal to the sine of 3x minus 2. But that's not going to work because the derivative of sine is cosine, and we don't have a cosine in this problem. So doing a u substitution and letting u equal sine is not going to be good. What's another name for 1 over sine, though? Somebody whispered it. Cosecant. So I can rewrite this problem as the integral of cosecant of 3x minus 2 dx. And now I can just look at my green sheet for the integral of cosecant. Cosecant is on here. It's number 18. It's negative natural log right there. I do have to have just a u here, though, so u is going to be 3x minus 2. du is going to be 3 dx. So right here's dx. I have to multiply both sides by 1/3. So we're going to have 1/3 the integral of cosecant u du. So now putting that all together with our cosecant formula, it's going to be negative 1/3 natural log, absolute value, cosecant, go back to the u, plus cotangent, plus c. On our last problem, this one is called a definite integral because we have numbers here. So we have to evaluate a specific answer on this one. So I've got to think of what I can do to simplify this. The best thing to do here is a u substitution, and this has a special case to it. On these other problems that we did earlier, we were always letting u equal the denominator. So like right here, we let u equal x squared plus 1. du was 2x dx. We needed an x dx. We multiplied by 1/2. We turned our problem into this. Okay? That's what we were doing on this side. Most of the time, the u was equal to the denominator. But on this one, letting u equal the denominator is not going to work. But think about letting u equal just the 1 plus natural log of x. You got to be able to think ahead in calculus. The derivative of that, what's the derivative of 1? Just what? 0. What's the derivative of natural log of x? 1 over x dx, right? See, that's what this really is. This is the integral from 1 to e of 1 plus natural log of x cubed times 1 over x. Do you see how that's the same thing? It's not like a natural thing. Like most of the time we don't think to let u equal this. But if you think ahead about what the derivative of that is and that the derivative is 1 over x dx, you can see that this is going to go away and be du. Okay, so now watch what happens. We've got the integral. This right here is du. What's this right here? Just, it's u, isn't it? So it's u cubed. Remember when we're doing a u substitution with a definite integral, we should change these. See, these are x's up here. We want to change them into u's. Okay? So plug 1 in for x, right here. 1 plus the natural log of 1. Anybody know the natural log of 1? It means e to what power would be 1? 0. So 1 plus 0 is just going to be 1. Plug in this one. This was x equals e. Plug that in for x now. 1 plus the natural log of e. That's what u is going to equal now. What's the natural log of e? E to the what equals e? 1. So what's going to go up here then? 2. If you don't know these, get out your calculator and do it. So now to integrate this, I would add 1 and divide. I put my numbers here, 2 and 1. And then I just plug it in. What's 2 to the 4th? 2 times 2 times 2 times 2 is 16 over 4. minus, plug in the 1. 1 to the 4th is 1/4. The answer is 15/4. Guys, on the quizzes, too many people are missing definite integrals too. See, this is the only thing that you can really check on your calculator. You should check it. If I wanted to check this, all I have to do is go to y equals, put in my original problem. I put in that original, I do a zoom 6 to graph it. Here's the way it looks. I go second trace. I want to find the integral from 1 to e. E is right here above the division symbol. So I can push second to get to that. So 1 to e, and it tells me the answer is 3.75. That's the same thing as 15/4. 3.75. You should never miss a definite integral because you can check it on your calculator. Okay? All right, so what I want you to do is I want you to finish the back of that worksheet that I gave you. And then I also gave you this other worksheet the other day. Looks like this. This is a really good review as well. So you should do, before you leave though, I want to see the back of this worksheet completely done. You only have like 6 more or something to do. And then you can go back and do the front if you still need practice with derivatives. And then you should definitely do this one, because this is very similar to what's going to be on your quiz. So if you can do everything on these 2 worksheets, you will be in good shape for this. And this is your last quiz on your own. You have 1 more quiz after this, and that one's going to be with a partner. So, all right. Any questions? Get started on that.
Answer this one, please.